Hello guys, welcome to day 55 Mikoma Data Science. Today the Tensorflow input pipeline and optimizing Tensorflow pipeline for a prefetch and catch. In Tensorflow input pipeline, it is a data API provide a powerful tool to build effective and scale input pipeline for the deep learning model. We can use a build the data pipeline for the deep learning model. It can use to directly manage the whole thing in just a few lines, such as image load image into number, converting number word to number, also filtering image and also scale the image. And another is prefetch. Prefetch means sometimes the memory and CPU and GPU train equally, they make some time to process step by step. Then we use a prefetch. They make save the time and sequentially, and they could not waste the time and will proceed. And the catch in TensorFlow, it's in help to when we train a model, it will be directly many times the load input function. Then there will be save the when we use the cache, they will be make save the time and do not load the many times the input. And let's come into screen how it's work. Few minutes. Both TensorFlow input pipeline optimizing performance, optimizing the TensorFlow input pipeline to achieving a high performance machine learning model by leveraging a technique like a prefetch, catch, and benching. You can significantly improve the thought and reduce the disk input output and ensuring the model are trained efficient. And understanding the TensorFlow pipeline data source. The input pipeline handling data from the various sources, including local file, remote server, and real-time data streaming. And another is data processing. The pipeline enable effectively data transformation such as resize, normalize, and argumentation to the prepare for the data train and bench and suffering. The pipe facilitate the benching and suffering of the data leverage parallelly to introduce the low randomness and during the training. Prefetch data improve the thoughts input is synchronized fetch. Prefetch data is allowed to model to continuously train while next bench to be prepared, begin to prepare, reduce latency by keeping the input pipeline filling with data prefetch minimum. The time spent waiting for the data improve the overall thoughting ports, optimize memory usage. Prefetch can configure to utilize the memory efficiently to balance the trade-off between a performance and resource compute consumption. Cache data reduce the disk input output performance boosting. Cache data in memory or local storage to significantly reduce the input output loading, leading to faster data accessing and training time. Reduce cost by minimize the need for the expense. Remote data retrieval cache can also help overall infrastructure cost for the machine learning workload. Improve reliability. Cache can make input pipeline for the reliance network or stronger failure in ensuring the uninterpretability for training and interface. Applying bench leveraging paralleling efficiently GPU utilization, reduce overhead and memory optimization. You must be read a sub big. You must be easily understand and improve suffering and randomness data. It helps to reduce overfitting, improve generalization, efficient training, and customizable strengths. Sorry. Entering variable length input padding, meshing, and dynamic benching. Padding also sum up border length around the border, and meshing is also technique to ignore padding to input during training and interface maintain the model performs a dynamic phase. Implementing a dynamic phase to handle variable length input and ensure the efficient resource utilization and the train the output. Sorry. Computer key takeaway prefeach synchronized training synchronized fetching data signification improve the throughput by the reduce the latency and optimize memory use and cache data can be boost performance, reduce cost and improve reliability and by minimize the disk input output fetching. Leveraging benching can lead the efficient GPU usage and memory optimization and reduce the computation overhead. And I also make notes for you. You must be read few minutes. Data pipeline overview. Create a data pipeline. You can easily import Tensorflow and easily. Some code are also imported. You must be see and map videos. Use the sub map band for repeat prepaid etc. We are also talking about previous and working with large data and also need more cache data and advanced technique for parallel processing, caching, summary of the whole data model, and optimizing TensorFlow performance prefetch and cache in deep learning. Here some brief information about that. You must be read. You can easily understand. And let's go into a code editor. Few minute. Here is a code. Here is a code for the data pipeline. You can easily see data pipeline using importing TensorFlow, creating a DF ID, list thought of the data iteration, iterate the thought of element by the element, iterate the first data set, first cell, converting a UF$. You can easily see shuffling, benching, also overall and loading image, count, also dog. You will also see you can easily perform. You need more information. We must be search in ChatGPT and also make more, provide more information about that and optimize the prefetch and cache version of the version of the TF TensorFlow hard code for the prefetch and benchmark. You can easily see and catch. And you guys also see my video. You must be like, share, subscribe, and save the playlist in your channel. And see you in next day.